Hi, this is section 10.5, objective 2, rationalizing denominators with one term. Okay, let me kind of go back on why we have to do this from something from 10.3. 10.3, we talked about conditions for simplified radical form, and number 2 says a radicand has no fractions, and then you cannot have a denominator as a radical. So that's why we have to do this. Okay, so I'm going to do the problems that are circled. There's 2 up here and there's 1 below here. So if you look up here, the process of removing radicals from the denominator is to what they call rationalizing the denominator. And we do this by multiplying a form of number of 1. Okay, so if I look at this first one here, okay, it's not simplified radical form because they have the square root of 3 on the denominator, and that's not allowed. So I'm going to multiply by 1. I have to multiply by whatever makes this a perfect square. So I'm going to multiply this by negative square root of 3. That way I get square root of 9, which is a perfect square. Whatever I multiply the denominator by, I have to multiply the numerator by the same thing. This is the same thing as 1. So that's what they mean by this part. Okay, now I'll go ahead and multiply my numerators. 8 times square root of 3. Multiply denominator. Square root of 3 times square root of 3 gives me square root of 9. And that just gives me 3. Okay, so that's my answer. Just a warning, you cannot cancel this 3 on the outside the radical with the 3 inside the radical. You can only cancel if they're both outside the radical or inside the radical. Okay, now I'm going to go over to number D, part D, I should say. Okay, so first thing I'm going to do is I'm going to write square root of 32. I'm going to write, I know that, well, let me just kind of put this here. I know that 32 is 16 times 2. And 16 is 4 squared. So I'm going to first rationalize this part, and then I'll worry about the radical in the denominator. Oops, so I have negative 16. I guess that's okay. 32 is the same thing as the square root of 16 times 2. Okay, I'll keep going down here. Square root of 16, that's just 4, so I get 4 times the square root of 2. Okay, we still have a radical on the denominator, and we don't want a radical in the denominator, so what we do is we rationalize it. So we multiply by a fraction, we multiply by whatever is left here, we're going to multiply it by again, so it becomes a perfect square. So I'm going to multiply the numerator denominator by square root of 2. You could cancel out right here, but I'm going to worry about that later. So I get 16 times the square root of 2, and I get 4. If I multiply these together, I get a square root of 4. Let me write that first. Okay, I'm going to go down here. Again, I'm going to reduce at the very end here. So this gives me 4 times 2, which is 8. And then I can reduce these two. 8 goes into here once and here twice. So my answer is negative 2 square root of 2. Okay, I'm going to do this example E finally, and then I'll stop there for this slide. Okay. First thing I would do is separate the numerator and denominator. And then I want to put both of these in simplified radical form. 8 is 4 times 2. 4 is a perfect square. 2 is not. And 45 is 9 times 5, where 9 is a perfect square. Okay, so I'm going to start working down here. So I get square root of 4 times square root of 2. I'm putting a lot of steps. You can skip whatever steps you want to. And then square root of 9 times square root of 5. So this becomes 2 and this becomes 3. And again, we cannot have a radical in the denominator, so now we're going to do the same thing as we did above there. We're going to multiply by 1. I'm going to multiply both the numerator and denominator by square root of 5 so that this becomes a perfect square. So I get 2 times the square root of 2 times the square root of 5 gives me 10. And 2 times the square root of 5 times the square root of 5 gives me 25. Okay, this does not simplify out, but this one becomes 5. And I'm almost out of room here, but I'm going to just kind of write the final answer down here. So I get 2 times the square root of 10 times 15. And again, I can't cancel these out because this is on the outside of the radical, this is on the inside radical of the radical. You can only cancel out if they're both outside the radical or they're both inside the radical. So there's my answer for that one. I also want to say for the homework, I actually did take these 2 out because of time. So you won't see these 2 in the homework. So that is 10.2 Objective 5.